welcome back once again to the maths class. In today's class, I am going to discuss with you exercise 2.4 of Polynomials chapter 2 class 9th. Right, Polynomials and Factorization, the chapter. Now, we were discussing this chapter since previous few videos. Those who have not watched the previous video, just click on the I button and get it notified. And in today's class, I am going to deal with you half of the exercise, and the remaining half exercise problems I will be telling you in the next video lesson. Now, before going into the exercise, now we will just revise the concepts. We have dealt with the remainder theorem. Now, today I'll tell you about the factor theorem. Now, factor theorem tells that here, if you take any polynomial, this is the factor theorem. If you take a polynomial p of x, and p of x is, if the p of x is divided by a linear polynomial x minus a, then if you get a remainder p of a, this is the remainder theorem, isn't it? Remainder theorem tells us when a polynomial is divided by a linear polynomial, then p of a is the remainder. That is the remainder theorem. Now here, factor theorem is nothing but this remainder, if it is equals to 0, if the remainder, that is p of a, is equal to 0, then this is called the factor of the polynomial. That itself the remainder. That itself is a factor theorem. Now, let me correlate both the theorems. I'll tell you here, when we are talking of remainder theorem, okay, here remainder theorem. So, if you are talking about remainder theorem, if p of x is a polynomial and if it is divided by x minus a, then p of a is the remainder. Okay, that is the remainder theorem. Now, what is the factor theorem? Factor theorem tells that if the polynomial is divided by x of a, the remainder which you get p of a, if the remainder is 0, then this x minus a is called the factor for this polynomial. That is the factor theorem. And after knowing these two theorems, this theorem we have dealt in the previous session also, and the problems are based on the factor theorem, the exercise 2.4. And after knowing the factor theorem, there are two conditions also given here. If I tell x minus 1 is a factor of any polynomial, cubic polynomial p of x, if p of x is a cubic polynomial, and if I tell x minus a is a factor, then the condition is that the sum of the coefficients must be equal to 0. Sum of the coefficients of the p of x, all the coefficients of p of x, if you sum up, if that sum of the coefficients is equal to 0, then x minus a is said to be a factor. This is one condition. Another condition is that if I tell x plus 1 is a factor, when we tell x plus 1 is a factor of a polynomial, say cubic polynomial, then the condition is that the sum of the coefficients of even powers, okay, is equal to the sum of coefficients of odd powers, okay, coefficients of odd powers. So, if this condition is satisfied, then simply we have to check this condition is satisfied, then x plus 1 is a factor of the polynomial. Here the first condition is that if x minus 1 is a factor, means the sum of all the coefficients of all the terms, if the sum is equal to 0, then I tell that x minus 1 is a factor. And if the sum of the coefficients of even powers, so 2, 4, 6, all those are even powers. For the even powers, the coefficients if you take to one side, and to the odd powers, the coefficients of the odd powers of x. Powers of x, we mean even powers of x or x square something, okay, of the variable. If the odd powers and even powers, if their sums are equal, then we tell that x plus 1 is a factor. So these two conditions are very important, factor theorem and the remainder theorem. Now let's quickly start our exercise problem. These polynomials has a factor of x plus 1. We have to determine. Now we know two conditions. One condition is that if the sum of the coefficients are equal, then we say that x minus 1 is a factor. If the sum of the even powers is equal to the sum of the odd powers, then we say x plus 1 as a factor. So here we have to check for x plus 1. X plus 1, we have to tell that here, let me write sum of coefficients, I'll write short, coefficients of even powers equal to sum of, okay, let me write it for this also, sum of the coefficients of odd powers. So if this condition is satisfied, then we can say that x plus 1 is a factor. Simply we have to check the condition. Now if you see here, what are the even powers? This is an even power, square 2 here, and also consider this as even power because x to the power of 0. Let us consider these two. So these two and these two. What we have to take? We have to take only the coefficients. So coefficient of x square is minus 1, okay, and coefficient of 1 just is 1 only. X to the power of 0, so coefficient is 1 is equal to, now even powers over odd powers. Odd power means cube and just here. So for this we have to see the coefficients. X cube coefficient is 1 and x coefficient is minus 1. So if you see here, plus 1 minus 1 is 0 equal to 0. That means this condition is satisfied, 0 equal to 0. So I can tell that x plus 1 is a factor for this polynomial. Yes. Is it a factor? It is asked. So yes, x plus 1 is a factor. Let us check for the second one here. Now if you see here like this, see this is even. So for 4, 2 and 1, we will write the coefficients. 1, here coefficient is 1. Along with the sign we have to write. So 3. So 1, 1 and 1. So it comes to 3 equals to, let us see the odd coefficients, this two odd coefficients, minus 1, minus 1. So minus 1, minus 1, that comes to minus 2. Is 3 equal to minus 2? No. So we say no. X plus 1 is not a factor. Okay, not a factor of this polynomial. So likewise we can check it. Let me do the third problem also from odd powers and the even powers. See here, even powers, the coefficients, just for the even powers you have to write the coefficients, okay. X to the power of 4, 1 is the coefficient, yes. Now for x square, 2 is the coefficient, 2. Now you have to consider even the constant, so 1. Here, odd powers, coefficients is 2 and 1. So if you see here, 4 is not equal to 3. So no, x plus 1 is not a factor. Not a factor, we can write. So we have to check the condition of some of the even powers and the odd powers. Now let's see this one. So this is cubic function. Here odd functions we'll take. Here this coefficient is 1. Here for x, coefficient is the complete thing. See here, minus of 3 minus root 3 is the complete coefficient along with the negative sign. Okay, here. Now if you take the even powers, see here, minus 1 and plus root 3. Now we'll open this, minus x minus 3, minus into minus, plus root 3. So if you see here, minus 1 plus root 3. Let us see here, 1 minus 3 is minus 2 plus root 3. So this is not equal to minus 1 plus root 3. See, if you see the condition. So the even powers is not equal to the odd powers. So here, no, it's not a function. It is not a factor. What is not a factor? X plus 1 is not a factor. Please pause the video and note it. Second one, use factor theorem to determine whether g of x is a factor of f of x in the following cases. I have noted down 2 problems here. There are altogether 5 bits here. I have noted down 2. Okay, here. Now if you see, f of x is a cubic polynomial and g of x is a linear polynomial. Now is this a factor of this? Now we know the condition for x plus 1. we know the condition of sum of the coefficients of even powers is equal to sum of coefficients of odd powers. If you check that condition, if that comes correct, so that means x plus 1 is a factor. But here asked use factor theorem. So factor theorem, what does the factor theorem tell us? If the remainder p of a equals to 0, then x minus is a factor. So we will use the factor theorem, not the condition, because given that factor theorem. So factor theorem means here, now here g of a is equal to, should be 0, okay. Now if I substitute this here a value, so if you take g of x is equal to x plus 1, isn't it? If you equate it to 0, so x is equal to minus 1, this minus 1, so g of a is minus 1, okay. So not g of a, here should be g of minus 1 should be equal to 0, that is the factor. So if minus 1 is substituted in f of, so I will substitute in the polynomial minus 1, wherever x is there we will substitute minus 1. Simply what we have done in the remainder theorem also, we were substituting the value of x. Now if the value after substituting, if it comes to 0, then we say this is a factor, right? So f of minus 1, 5 into minus 1 whole cube plus minus 1 whole square plus 5 into minus 1. So if you see here, minus 1 whole cube comes to minus 1, okay. Minus 1 into 5 is minus 5, minus 1 whole square is plus 1, okay. Minus 5 minus 1, so that comes to plus, this is multiplied, so plus, so minus 1. If you clearly see, minus and plus gets cancelled, minus and plus gets cancelled, so we get it as 0. If the value is 0, then we tell that x, so we got this as 0. So minus 5 plus 5 minus 1 plus 1, so all get cancelled, so we get it as 0. So if the polynomial value that is 0, that means if g of a is 0, if we get, then x plus 1 is a factor according to the factor theorem, right? Is a factor. So we are checking this for factor theorem. If it is not mentioned in the question factor theorem, then we can go for the conditions. For x minus 1, x plus 1, you can go for the condition of sum of the coefficients, okay. Now let's see the third problem. Now I had written first and I have not written the second one. Do practice it for yourself. In mathematics, now I am telling everything and you are just simply merely listening, it doesn't work out. So if you practice the sums, it will work out. So practice the second bit for yourself, that is for your homework. Now coming to the third bit here, f of x is given and g of x is given. Is this a factor? So we have to substitute the value of here. Let me equate it to 0. So that comes to x. If 2 comes that side, it comes to 2. X is equal to 2. We have to substitute 2 here, f of 2. If this value goes 0, then I tell that x minus 2 is a factor. So f of 2, so 2 cube, 4 into 2 square, in place of x, what am I doing? I am substituting 2, okay, plus 6. So 2 cube is 8, 2 into 2 into 2, 8. So minus 2 square is 4, 4 into 4, 16, plus 2, plus 6. So like terms, like all the singular terms, we'll add it, see, 6, 2, 8. 8 plus 2, 10, 10 plus 6 is 16, 16 minus 16. So that comes to 0. We got it 0. Therefore, what do we tell? G of x is a factor of f of x. G of x is x minus 2. Therefore, g of x is a factor of f of x. Please pause the video and note it down. Let's see next sum. Fourth and the fifth problem I have noted. All 5 problems I have given for you to practice in only the second problem. Now the fourth problem, f of x is given and g of x is given. So we have to check whether this g of x is a factor of this. So what we will do, we will start with g of x, equate it to 0 to get the value of x, okay. So that is 3x equals to, if 2 comes that side, 2. X is equal to 2 upon 3, 2 by 3. So we will substitute in place of x 2 by 3 here. So f of 2 by 3 equals to, wherever x is there, you have to substitute 2 by 3. 3 into 2 upon 3 whole cube plus x square is 2 by 3 whole square minus 20 into 2 by 3. plus 12. Okay. Now here 3 into 2 square, 2 cube is 8. Okay. 3 cube is 27 plus 2 square is 4. 3 square is 9 minus 22s are 40 by 3 plus 12. Let us see here. Now, a few terms we can cancel off, isn't it? So, 3 ones, 3 nines are 27. So, here it comes to 8 by 9 by 4 by 9 minus 40 by 3 plus 12. We can take LCM, isn't it? We can take LCM as 9. Right, 9 ones 9. So, 8 here plus 4 here minus 3 threes are, so 120 here plus 1 nines are, and here see when you are taking LCM, see 12 means 12 by 1, that is a rational number, isn't it? So if nothing is there, you can take denominator as 1. So this is 108, 12 nines 108. So if you add here 108 and 12, 108 and 12 comes to plus 120 minus 120 divided by 9, this is 0 by 9, that is nothing but 0. We got the value of this as 0. That means this is a factor of f of x. Therefore, g of x is a factor of f of x, we can write. Okay, right. Now we will move on to the next one. Here, g of x given as 2x plus 3. So let's take g of x, the divisor here. We will equate it to 0 to get the value of x. Now 2x equal to minus 3, x is equal to minus 3 upon 2. So I'll substitute f of minus 3 by 2. We will substitute in place of x minus 3 by 2. So let us substitute 4 into minus 3 by 2 whole square plus 20 into minus 3 by 2 whole square. The first one is cube, here. Now plus here 33 into minus 3 upon 2 plus 18. Okay, I'll write it here. So that comes to 4 into minus 3 whole cube. So let me write into minus 3 whole cube is minus 27 by 8. Okay, plus 20 into 3 square is minus 3 whole square is 9 by 4. So 20 into 9 by 4 I can write here. Here we can multiply 33 into 3 is 99. So that is minus 99. I'll write minus because minus sign is there. Minus 99 by 2 plus 18. We got it here. So we will cancel off 4 ones, 4 twice, 4 ones, 4 5 times. Right. Here we get it as minus 27 by 2. Here we get it as 45. 9 5s are 45. Okay. Minus 99 by 2 plus 18. So we will take the LCM part here. If you take 2 and 2, LCM is 2 only. Okay. So minus 27 plus. So here 1. So that comes to 90. I'm taking the LCM minus 99 plus 36 here. Now, if you add this negative signs to 99, 27 and 91 here. See, we will do here minus 27 minus 99 and here 90 and 36. We will add them. Here 6, here comes to 20. Here also 6 and here 126. But this is minus 126 plus 129. That means minus 126 plus 126 divided by 2, that is 0 upon 2, nothing but 0. Then we say g of x is a factor. Therefore, so there is no space here, g of x is a factor of f of x. Okay. Please, if you can't see here, I'll tell you g of x. So we got 0 as the remainder. So g of x is a factor of f of x. So with this, we completed the second bit also. So we will please pause the video and note it down, and we will continue the rest of the problems of this exercise in our next session. Hope you have understood. Thank you all.